Please don't forget to subscribe to my YouTube page and like, comment as well, and also hit up the bell button to get notified for new videos. So now we want to solve past questions for MAT103. So first we are starting with 2014/2015 session. So the first one here, we are asked to find the derivative of this very guy here, which is y equals to 2x squared minus 3 all power 2/3. You see guys, this is a chain rule type of question. This is a chain rule type of question. So we're going to use chain rule to solve this very question because of the way the question seems to appear. Okay, so in this case now we are applying chain rule. That is by method of chain rule. Now if I'm applying chain rule, now watch what I am about to do here. You see here we have y is equals to this, so I'm taking everything here as my u. So I'll say, okay, let u be equals to 2x squared minus 3. Now I'm differentiating u with respect to x now. And I'll say, okay, the u over the x here is now equal to, here will give me 4x, and that is all. I'm done with this one. Next, now remember I made here to be u. I'll now say, okay, next now I have y is equal to, in place of everything here, I'm using just u, because I've named it to be u earlier, and which is this, u raised to the power of 2 divided by 3. Next, I want to differentiate y with respect to u. Now I have it as the y divided by the u is now equal to, by the general formula for chain rule, this guy becomes, this 2/3 will come down, it becomes 2 divided by 3. Now u power, I have it as 2/3, then minus 1. Okay, now guys, let's work out this one, the LCM. I have it to be 2/3 minus 1 here over 1. The LCM here is 3. 3 divided by 3 is just 1. 1 times 2 is 2 minus 3 divided by 1. It's 3. 3 times 1 is 3. So 2 minus 3 will give me minus 1/3. So now guys, I have the y over the u here, just this one, is equals to 2 divided by 3 u raised to the power of minus 1/3. Now the formula for chain rule is this: the y over the x is equals to the y over the u multiplied by the u all over, this is the u over the x. So this is the formula for chain rule with respect to the variables given. So we have here y and x, so that's why we're using y and x here. And chain rule can otherwise be called function of function. Okay, now let's substitute our answers here. The y over the x here is equal to, now remember we've solved for the y over the u, so and this is my value for the y over the u. So my the y over the u is 2/3 u power minus 1/3 multiplied by the u dx is what? Is 4x. Here is 4x. So next now, what do we do now? Let's simplify further. This guy can still be written as this. We can write this one as 2 divided by 3. Okay, then multiply by 1 all over u power 1/3. You see here I apply law of indices in this case. Then multiply by 4x this way. So now here I have it to be 2 times 1 here is 2 all over 3 u 1/3 multiplied by 4x this way. So now this guy can still be written as this: 4x times 2 is 8x. 8x all over 3. I can take the cube root of this one, so it can be written in this format. This 3 can come in here by that same law of indices, and here is u. Okay, alright guys, now but remember we said earlier that let our u be equals to 2x squared minus 3. So I'm going to put this guy down here. So finally my answer to this very question is 8x all over 3 open brackets. I have it to be the cube root of, I'm putting down my u now, which is 2x squared, then minus 3. Okay, this is my answer for the first question, guys. So the answer for this very first question is 8x all over 3 open bracket. That's very high. Okay, so please get this down and understand it very well. So when I'm done solving the past questions for MAT103, I'm going to bring out a short method for solving the chain rule question in my in my other videos as well. Okay, now let's proceed to question number 2. Alright, so okay, from the past question given to me here, the answer here I think is C. C happens to be the answer. Alright, now let's proceed to question number 2. Okay guys, now question 2 says find the first derivative of x squared plus y squared equal to 25. You see, now let's move on from here. Solution to this very question. You see, a question whereby I think I explained this very type of question in my other videos. Here we have x and y, they are mixed up together, equals to 25. This is an implicit type of question. Why? Because we have two variables on one side of the equation. Okay, is that we have both the dependent and the independent variable on one side of the equation. So it's an implicit type of question. So this question can be written, this way, which is x squared plus y squared and minus 25 is equals to 0. Okay, so by the formula for implicit, it's the y over the x is equals to minus f x over f y, f of x over f of y. Okay, now next we just need to obtain the value of my f of x. Now I want to differentiate this very question here with respect to x only. This guy, is constant, so it's 0, and this y here is 0, and this y square here is is actually the constant, and this is 0. So I'm only differentiating this one that has x, and you only have it to be x square here only. Okay, so this one say when they consider they are constant, and so therefore they are 0. So if I differentiate x square here, I will have it to be 2x. Now coming over to this place, now I want to differentiate f of y here in this case. Now the same thing here, this is 0, they're all constant. I don't need this one, I only need to differentiate this, okay, with respect to y, and this will give me 2y. Alright, so next applying the formula says the y over the x here is equals to minus f of x over f of y. So finally I have my dy over the x is equal to minus my f of x here, guys, is 2x, and my f of y here is 2y. So lastly, 2 can cancel 2. My final answer becomes minus x over y, and that's all. So this becomes my final answer. And I think in the first question there is just maybe what is the answer here? Okay, A. They choose A as the answer there. So now let's move on to question number 3. It says we should integrate this very guy. Now we are asked to integrate this is 5x minus 4 raised to the power of 6 dx. Now we want to integrate this. You see, this sign here is the integral sign, and the content to be integrated is called the integrand. Okay, this is the integral, this is the integrand. So now how do we go about this now? So let's fire down, guys. So now I can just I will say let my u be equals to 5x minus 4. Okay, let me divide it board. Now let me differentiate this guy, which is the content in there. The u with respect to the x now is equal to 5. Okay, now but guys, watch. My aim now, I want to get the value of the x. I need to obtain this value of the x here. Okay, so now I have to cross multiply this way. The u times 1 here will give me the u. It's equals to 5 times the x will give me 5 the x. Now because I want to obtain the value of the x, so I will divide both sides by the coefficient of the x. This way, here 5 here, here 5 here, let's go with this one. So therefore my dx now is now equals to du over 5. Du over 5. Okay? Now, anywhere I see the x, I'm going to replace it with du over 5. Now, coming over to this place now, I have it as integral of, remember I already mentioned here or named here to be u. So this guy becomes u power 6. I can't, integrate u with respect to x. No. Remember, we've gotten the value of the x to be du over x. So this guy becomes du over 5. So instead of putting the x, I'm using du over 5. Okay? So now, in this case now, this one, I can still write this guy as 1 over 5, then factored out, then integral of u power 6 du. So this will give me 1 over 5. Okay, if I integrate this, this will give me u power 7. Okay, let me just break it down. This is 6 plus 1 over 6 plus 1, then plus m. It's a constant. Our m there is the constant. Alright, so now I have it to be 1 divided by 5. Okay, then multiply by u power 7 all over 7 plus m being the constant. So let me clean this very place. I believe here is talking. Let me clean this very place. What I'm finding. Alright guys, now let's move on to this place. Okay, what I have next now. So finally this implies that I have 1 times u, this 1 times u power 7 will give me u power 7, all divided by 5 times 7 will give me 35 plus the constant, say m as the constant. But remember we said let our u be equals to 5x minus 4. So this guy becomes finally as, in place of u, I'm going to put it as 5x here minus 4 power 7 divided by 35, plus m, say constant. So this is my final answer to that very question. In your past question here, the answer is not there. The answer is not there, okay? Alright, so guys, let's move on to question number 4. Alright guys, now let's move on to this application of integration question. Question 4 says find the area of the region bounded by the graph of the equation this, and this is the bound given to us here. First of all, I want to explain something. Let me throw more light on this. This is a roster method of set. Sorry, the set with that form actually. So here I want to split this together. If 2 is actually less than or equal to x, if 2 is less than or equal to x, at the same time x is less than or equal to 5, this could still be written as x is greater than or equal to 2, at the same time x is less than or equal to 5. So this is the starting point of x and this is the terminal point. Okay, so now here we go. The formula for this is the area is equals to the integral of y dx. Okay, so this is how we go about it. Now this will be my y actually. So let's integrate this. We have area here is equal to the integral now of 2x squared plus 4x plus 3 dx. You see, now I want to integrate this. So but starting from what this is starting from 2 here, and this is 5. The boundary given to us here from 2 to 5. So it's just in form of definite integral, okay, that has boundaries. So now I want to integrate this very question here, this very term here. So how do we go about it now? Okay, now this will give us, let me bring out the 2 outside. I will integrate them part by part. This is 2, which is the constant, the integral of x here, x squared. I'm integrating this one, the x plus this 4 here. I'm bringing it outside for integral of x here, then the x plus this is just 3, so integral of 3 dx. But not to forget they have boundaries from 2 to 5, from 2 to 5, this from 2 to 5. Okay, so now what next, guys? Let's move on. So if I integrate this one directly, so I'll be having 2 here. Okay, here will give me x 2 plus 1, which is 3. I'm still putting down the 3 down here. Okay, plus here will give me 4 x power, this is, no, there's 1 here actually at the top, which is 1 plus 1, that is 2 divided by 2. Alright, then here plus, that will give me, if I integrate 3 on its own, to give me 3x with respect to x. Okay, so the boundary is from 2 here, then to 5. Alright, so now guys, here will give me 2x power 3 divided by 3, plus 2 here is 1, 2 here is 2. I have 2 square plus 3x here. Now with the boundary 2 here, then to 5. So now I'm going to substitute, starting from the upper bound there. So this guy becomes, let's create a bracket here. So now at first here, anywhere I see x, I'll be using 5 for the first time. Or in my first substitution, this guy becomes 5. This is 3 here, this is 3. Plus here becomes 2. Yeah, this is 5. This is square. Plus this is 3. Here becomes 5. Okay. Now minus, now the lower bound, this is 2 open bracket. In place of x, I'm putting down 2. This is cube divided by 3. This is plus. Here is 2 open bracket. This is in brackets 2x. Okay, 2x square. That is 2 square plus this is 3. Anyway, I see x, I'm putting down by 2. This way. Okay. Wow, that's good. So let's move on, guys. All right. Now, what I have here. Now we are going to start with the brackets first, not the outside one. We will obey the board mass rule here. So 5 raised to the power of 3 is 125. 125 then times 2 is 5 raised to the power of 3 here is 125 times 2 is 250. 250. Okay, now divided by 3 plus 5 raised to the power of 2. 5 raised to the power of 2 here is 25, then 25 times 2 is 50, plus 5 times 3 is 15. I have this one here, minus 2 power 3 is 8, then 8 times 2 is 16, 16 divided by 3 plus here 2 raised to the power of 2 is 4, 4 times 2 is 8, plus 3 times 2 here is 6. So now what next? Let's simplify further. Okay guys, so let's take LCM here. So this is like over 1, this over 1, this over 1, and this is over 1. So the LCM here is 3. 3 divided by 3 is 1. 1 times 250 would give me 250, plus what I have next now, 3 divided by 1 is 3. 3 times 50 will give me 150, plus 3 divided by 1 is 3. 3 times 15 would give me 45. Then I have here, minus, here the LCM 2 is 3. So 3 divided by 3 is 1. 1 times 16 is 16, plus 3 divided by 1 is 3. 3 times 8, that's 24. Plus what I have here should be 18. Well, I'm fine. Okay, so now let's move on. Good. So if I add 250 plus 150 plus 45 would give me 4, 4, 5. Yeah, over 3. Then minus 16 plus 24. Then plus 18 would give me 58. 58 over 3. Yeah. So now the LCM here is 3, 3. By mathematics, we are going to pick up a single 3 since they have the same denominator. So I'll be having 4, 4, 5 minus 58. which will give me 300 and that's 387 divided by 3. So let's move on now. So 387 divided by 3 will give me 129 then unit square, and that is it. So this is the answer to this one, 129 unit square. And you know, let me see what they chose in their question. Right, whichever is A. Okay, so 129 unit square is the answer. Alright guys, so let's move on to question number 5, I guess. Question 5, yeah. So let's move to question number 5. Alright, let's move. Question number 5 says we have now y prime, that is y power triple prime is equals to 4x squared minus 5x plus 8 minus 1 over x. You see, this is under, still on differentiation, but further derivative, where you have to differentiate, in furtherance. So it means we're going to be differentiating, 3 times subsequently from the answer, gotten. Okay, so let's move on now. Sharply, guys, solution. The first one here is this. So let me get my y prime, guys. I'm differentiating this guy now just once. Now let's move on by applying the general formula for differentiation. So 2 times 4 is 8. I have 8 here. X 2 minus 1 is just 1. I'm done with this guy. Minus 5x here is just 5. Okay, I know here is 1 minus 1, which is 0, and x power 0 is just 1. 1 times 5 is 5. This 8 here is not with respect to x, so therefore it has to be disrespected by being 0. Okay, next we have 1 over x. Okay, this 1 over x now, let me do it separately now. You see, 1 over x, I want to differentiate minus 1 over x. Okay, now let me do it separately. Minus 1 over x can still be written as minus x raised to the power of minus 1 by law of indices. So this one now, so let me now differentiate next. So this will give me bringing this minus 1 to multiply this minus here, I will have it to be plus 1x, then minus 1 minus 1, which is minus 2. Okay, so lastly I'm having just x power minus 2, which can still be written in fraction form as 1 over x power 2. So here I now have it as, lastly, here I'm having it as plus 1 over x, power 2. So this guy now is my first derivative. Now I want to get my y prime. My second derivative, which is just my y prime. Yeah. So now I'm going to differentiate this one again the second time. If I differentiate 8x with respect to x, I should be having just 8 on its own. Okay, so this 5 here is 0. It's not with respect to x, so we just ignore this. So now I want to differentiate this very particular one, which is 1 over x squared. Okay, now to differentiate 1 over x squared, which can still be written, as x raised to the power of minus 2 by law of indices. So when minus 2 comes down, it becomes minus 2x minus 2 minus 1, which is minus 2x power minus 3. So which can still be written as minus 2 all over x power 3 this way. So now I have it as minus 2 here over x power 3. So this is my y prime. So now guys, lastly I want to get my y prime. That is the third derivative. That is from this answer here. So what do I do now? I'm still going to differentiate this one again with respect to x. So taking it separately, this 8 here does not contain x, so it is wiped off. So I just need to differentiate this very guy here, which is minus 2 over s cubed. Okay, so to differentiate this one now, I have it to be, minus 2 over s cubed, right? We need to differentiate this guy, which can still be written as earlier minus 2x power minus 3. So now let's move on now. What I have here now, minus 3 will have to come down to multiply minus 2 x here minus 3 minus 1. So this guy gives me minus times minus is plus, 3 times 2 is 6. Then x here would give me minus 4. So lastly, in fractional form, it can be written as 6 multiplied by x power minus 4, which is 6 times 1 over x power 4. And lastly, I have my answer to be 6 all over x power 4. So this is my answer for question number 5. Okay, so that's it. Let's move to question number 6. Okay guys, now with question number 6, question says okay, it says suppose y is equals to 5 raised to the power of x. Now we should find the y dx. So let's put down solution sharply and so we solve. Here is kind of a constant powering a variable. Okay, so to get this done, we need to apply what we call the derivative exponent rule. We need to apply what we call the derivative exponent rule. Okay, so by that rule, the rule states that if we have ax here, now if you actually differentiate, or if y is equals to ax, you still should find y dx. I'm giving an instance. So this one, the rule states that whenever we have a constant powering a variable, this guy can be written as a raised to the power of x, then ln a. Okay, so here will be a raised to the power of x, then ln a. So now since we have y is equals to 5 raised to the power of x, so this one equally, by applying the derivative exponent rule, it's just gonna be by applying this very rule here, this very formula. So it's just gonna be, this a here is the constant, so it's gonna be 5x here ln 5, and that's all. We don't have much work here. Okay, just apply this formula to give a 5x here ln x, and that's all. Okay, now guys, for question number 7, we say if y is equals to this very guys, I'm sure we should find the y over the x is also y prime. You see, we have two sections or two compartments of x's here. So this guy will be solved using the product rule, because they're multiplying themselves. So it's going to be solved using the product rule. Okay, and the formula for product rule is the y over the x is equals to u the v over the x plus v the u over the x. This is the formula for product rule, and they are still commutative. It can still be v the u plus u the v. So now I will have to make this one my u, this my v. Now, okay, by assumption, let u be equals to x cubed plus 5x, and let v be equals to 3x squared plus 2. Okay, so now let's move on to differentiate. Let me just come here now. Now my du, let me just go up here. My du here with respect to x, I'm differentiating this one now with respect to x, so it's gonna give me 3x squared then plus 5. Now let me do that of the v here with respect to x. It's gonna give me, here will give me 6, because 2 times 3 is 6, then x, 6x. This guy is 0 because it does not have x attached to it. So now let's move on. That's all. By the formula, the y all over the x here is equal to my u here. This is my u, okay? My u is s cubed then plus 5x. Now dv dx now is 6x, then plus my v is 3s squared plus 2, 3s squared plus 2. Then my du dx now is this guy, which is 3s squared plus 5. Now let's do the simple mathematics in there. Using this to multiply the 6x times s cubed will give me 6x power 4 plus 5x times 6s will give me 30x squared plus, now let me multiply 3s squared times 3s squared will give me 3 times 3 is 9, which is 9x raised to the power 4. 3s squared times 5 will give me 15x squared plus 2 times 3 will give me 6x squared plus 2 times 5 is 10. Okay, so let's fire on, and that's it. Good and fine. Now let's move on. Now I have to collect like terms here. This one will have power 4 raised to the power 4. So 6 plus 9 is actually 15x raised to the power of 4. Then next, let's go for the ones that has square. 30 plus 15x squared. 30x squared plus 15x squared will give me 45s squared. 45s squared plus 6s squared will give me, I think, 51x squared. Then plus 10. So guys, this is my final answer for question number 7. Alright, I hope this guy is meeting you very well. Okay, so just by method of product rule. So now let's move on to question number 8. Okay, now after that, let's move on to question number 8. This question number 8 is a question that can be found in limit of a function. Okay, so this is a limit of a function type of question. You say lim. Okay, let me put down the lim where it maps to. Okay, here is y approaches minus 2. Y approaches minus 2. Okay, now guys, we are given this thing to solve. Actually there are about 4 methods of solving, basically 4 methods of solving limit of a function. The first one is by direct substitution. The second one is by factorization. The third one is by thumb rule or the reduction method, while the fourth one is by the L'Hopital's rule of differentiation. So just that, the one thing I want to make you understand is in this question is this: when a question is given, you can have 0 as an answer, but we are not expected to have undefined or indeterminate when it comes to a limit of a function. That is why we have varieties or various methods of solving. Okay, now let me apply by direct substitution by ds, which is direct substitution. So I want to substitute y for minus 2 in this very term here. So what I have here now, I have it as, in place of y, I'm having minus 2 here. Okay, let me just go directly. Now minus 2 here plus 2 all over here is minus 2 all square plus 5 here. I have it to be minus 2 then plus 6. Minus 2 plus 2 is 0 divided by minus 2 square here. It's 4. Okay, here is 4. Then here is minus 10 plus 6. So I have it to be 0 all over. Here's minus 6 plus 6, which is 0 over 0. And this happens to be undefined. Guys, like I said earlier, we wouldn't want to have undefined. We can have 0 as an answer, but we would not accept undefined as an answer. So we have to, use another approach or method to solve this very question. So this fail now. Now let's solve by factorization method, because the denominator can actually be factorized. So now let's work on the denominator now. That is the denominator. We have y squared plus 5y plus 6. Let's factorize this expression. And definitely the two factors of, the factors of 6 here will be 2 and 3 that will complement this very, system. So I'm having here to be y squared plus 2y then plus the 3y then plus 6. Now let's move on this way. What's common here? Y is common. I have y here then plus 2. Okay, then plus 3 is common here, then y plus 2. So I'm having it to be y plus 2 here and y plus 3. So these are my factors. Okay, All right, now let's go back to the question. The question says I have lim y approaches -2, then open brackets, let me put it this way, this is y plus 2 here, okay, that's this one. Then in place of this denominator, I'm going to use the factors I got earlier. So I have these 2 here, here is y plus 3, so at a glance this can cancel this. I have 1 left up there, so now I should be having 1 divided by y plus just 3. I'm having it as lim y approaches the -2, so this would give me 1 over -2 plus 3, which is 1 over 1. So finally guys, my answer is 1, and that's all. So the answer to question number 8 guys is 1. Okay, good. Okay, question number 9 says what is the derivative function of this? Okay, solution. You see, when we are given y equals x squared minus 5x raised to the power of 3 divided by 2, this is a chain rule type of question. Okay, now I will say let u be equals to everything in the bracket, which is x squared minus 5x. Let me differentiate this u with respect to x, which is the u divided by the x. So now x squared would give me 2x, then 5x would just give me -5. I'm done with this guy. Now I will also, okay, for the y aspect, y is equals to u raised to the power of 3 divided by 2. Okay, now guys, I want to differentiate the y with respect to, to the u. Alright, so this guy becomes, I'm bringing this one top here down, it becomes 3 divided by 2, x 3 over 2, then minus 1. Okay, now let me work this one separately. I have 3 over 2 minus 1 over 1 here. This is 2, this is 3. What I have next now, this is 2. Finally, I have it as 1 divided by 2. Okay, so now I now have this to be 3 over 2 u power 1 over 2. Alright, so now by chain rule, the formula is the y divided by the x is equals to the y over the u multiplied by the u over the x. So the y over the u here is this. This is my y over the u, which is 3 divided by 2 u power 1 over 2 times the u over the x is this. Okay, which is 2x here minus 5 this way. Okay, next now, okay, now finally this will give me 3 over 2 root of u, times 2x minus 5. So I should be having 3 divided by 2, then square root of, remember we said that about u be equals to x squared minus 5x here, then multiply by 2x here minus 5. So guys, this should be my final answer this way. Okay, all right, so the last one for this 2014-2015 section, that's question 10. Okay guys, let's solve the last question for this session. They say we should find the differential of this guy. Now this is a quotient rule. Quotient rule has to do with having a term at the numerator and denominator. Okay, it will be rational. So this guy becomes quotient rule. I'm going to apply the quotient rule method. The quotient rule method. The quotient rule. Now by quotient rule now, the formula is the y over the x is equals to v du over the x minus u dv over the x now all over v squared. This is the formula for quotient rule. Okay, so So take note of this guy, you'll be needing it further. Now let my u be equals to the numerator. This is how we go about it, and my v be equals to the denominator, and this is it. Now if I differentiate here, this is the u with respect to the x. Here will give me 3x squared. And if I differentiate here, the v with respect to the x, here will just give me 1. Alright, how 1? This guy is 0, and the derivative of x on its own is just 1. So that's all. I also get my dy over the x is equal to v. What's my v, guys? Remember we said let v be equals to x plus 3. Okay, then multiplied by, what's du dx? Du dx is 3x squared minus, guys, what's my u? My u, 3x minus 2. My dv, guys, times 1 all over my v is x plus 3 all square. So now let's multiply. Further, 3x squared times x would give me 3x cubed plus 9x squared, minus the same thing here would give minus s cubed, then plus 2, minus s minus is plus, all over s, plus 3 all square. Alright, now let's proceed. Okay, so now guys, let's move on. Now by collection of like terms, 3s cubed minus s cubed would give me 2s cubed, then plus 9x squared and plus 2 all over x plus 3 all raised to the power of 2. Okay, so can anything be done for? So guys, I think nothing else can be done for that. We can just stop here, for now. The aim here, in these derivatives here is that we've been able to, show our v du dx minus u dv dx over v squared. Okay guys, these are the solutions for MAT103 2014/2015 session. Please do not forget to subscribe to my YouTube channel for more videos as we progress into the system. Okay, I wish you guys success in your tests and exams as well. So I hope this video meets you guys very well. Good luck and have the best wishes. Okay, bye.